Hey guys, today we're going to be talking about transformations. So transformations, they have to deal with different polygons, points, lines, all on the coordinate plane and moving them around. So we define a transformation as the movement of a figure in a plane. And when you have a transformation like what you're doing, let's say we just have like a square, is you're going to do something to the square. You might just be like moving it around. You might be reflecting it or rotating it around, or somehow making it larger or smaller. You're somehow going to change this square, whether it be the position or the size of it, whatever it may be. Now whenever you're doing something, let's say all we do with this square is we move it. And we'll learn about this today. So we're not going to change anything besides the position of it. You have what you call the pre-image, which is where you started at. It's your original. So this would be like your pre-image, and then we moved over here. That's going to be the final image, which we just call the image. The way we notate this is, well, let's say we had some of the points here. Let's say we had this as point A, this was point B. So the original, your pre-image, they're just regular points. In your image, we put these little markings up here. We call them little prime symbols. And it's just to indicate that now this is after we've done something to the original image. So this would be A prime, B prime. So these little prime symbols just mean that we've done some sort of a transformation. And then if we did another transformation, to indicate that we've done two transformations, and to kind of tell the difference between them, we could do two of those symbols. So A, we'd call it double prime, and B double prime, just to indicate that now, and this would become our image because this is the final. So this would be like our final image here, and we've done two transformations to it. So pre-image and your image is where you ended up. That'll be important. With transformations, we're going to focus on 4 of them, but first we're going to really focus on a certain 3. There's 3 transformations that they have a special property. So the transformations, one of them is a translation, and we're going to talk about those today. We also have reflections and rotations. There is a 4th that we'll talk about in the future, but these 3, all 3 of these, they have one special property, and it's that after you do one of these transformations, the figure is, I believe we talked a little bit about this word, the figure is congruent, meaning it's the same size and the same shape. So the only thing that changes is the position, or maybe like the orientation if it's been reflected over, but it's still the same size and the same shape. So these 3 transformations, they remain congruent with your pre-image and your image. And today we're going to focus on a translation and what that is. So we have transformations, but we're going to go into a special type of transformation, and that's called a translation. A translation, if you're following along with the slides, it says on here, a translation is a slide. And that means that each point is going to be moved in the same direction, and it's going to go the same distance, but the figure is not going to rotate around, it's not going to reflect over, it's just going to slide around. Like if I took this eraser, all we're going to do is keep this exact same position, but now we're just going to slide somewhere and slide somewhere. We're not going to rotate. We're just going to keep the same orientation and just move around. That's what a translation is. So you're just moving around the coordinate plane. You're not rotating. You're not reflecting things over. You're just sliding around with the same orientation. And we can do this by looking at ordered pairs. We can really find out coordinates. So if we have some shape, some polygon, maybe it's XY, when we slide around the coordinate plane, we're going to change by x plus a, that's just how much you're going left or right, and y plus b. So this is how much you're going left or right. Left or right. And then b is going to be how much you went up or down. And this is just indicating when we see this notation here, you also may see it like this with these special, we call these vectors, translation vector. You could see either way. This just indicates how much you're changing in the horizontal direction and the vertical direction. And what we mean by that is if we take that triangle we have on the slides, this is, I think, the same triangle. All that would mean is, like, let's say we take this triangle and we're going to translate everything up 2 units, and we'll go up 5 units and to the right by 4. So we'll go up 1, 2, 3, 4, 5, to the right by 1, 2, 3, 4. So like this, if we called it A, would be translated up 5, to the right by 4 to A prime. And every single point on this triangle is going to do the same. So everything's going to go up 1, 2, 3, 4, 5, 1, 2, 3, 4 to the right. We'll call this B and B prime. And then this bottom point here we'll call C, goes up 1, 2, 3, 4, 5, 1, 2, 3, 4, over to the right by 4, that's C prime. And we'll end with a triangle like this. Same exact size, all we did was slide it up. In fact, we slid it up 5 and to the right by 4. We'd indicate that by saying x plus 4, because we went to the right by 4, and y plus 5, because you went up 5. And you also could see that like this, x plus 4, y plus 5. This is just a special notation for that. It works just for translations. So whenever you're going to the right, you're going to be positive. If you go to the left, you're going negative. Whenever you go up, you're going positive. Whenever you go down, this would be negative. So if we went down 5, it'd be like minus 5. And those are the keys to translations. All right, so we're going to hop into doing a few examples of these, and then you can try some on your own. So our first one, it says, draw triangle GHJ with vertices. G is negative 4, 1. So G is negative 2, 4, 1. This is G. H is negative 2, 4. So here's H, here's G, and J is 0, 1. And here's J. So here's our triangle. This is our pre-image. It's where we're starting. And we want to translate down 3 units and 4 units to the right. So we're going to go down 3 and to the 4 units to the right. So I'm going to go with each vertex of this triangle and go down 1, 2, 3, and to the right 1, 2, 3, 4. Now I started at J, so that means I'm ending at J prime. G is going to go down 3, 1, 2, 3, to the right by 1, 2, 3, 4. So that becomes G prime. And H would go down 1, 2, 3, and to the right by 1, 2, 3, 4. So here's H prime. And your triangles should be congruent. They should be completely the same. If for some reason like G prime ended up over here and my triangle looked weird, I would know I made a mistake, because it should be identical when we're doing a translation. And again, this was going, well, x was going to the right by 4, so this was x plus 4, and this was y minus 3. So one way you can do it right on the coordinate plane is just count how many units you're changing by. We're going to look at this one in another way as well. Maybe we didn't want to do it on the coordinate plane. So maybe we wanted to take our original points, and this can be a little bit quicker sometimes. We had G was negative 4, 1, H was negative 2, 4, and J was 0, 1. And we said we're going to the right by 4 and down 3. So that means each one of these is going to go through the translation, the transformation of x plus 4 and y minus 3. So this is another way you could do it. X plus 4, y minus 3, x plus 4, y minus 3. And if you apply that here, negative 4 plus 4 is 0, and then y minus 3, so 1 minus 3 is negative 2. So that means G prime is negative 4 plus 4 is 0, 1 minus 3 is negative 2. H prime, negative 2 plus 4 would be a positive 2, 4 minus 3 would be 1, and J prime, 0 plus 4 is 4, and then 1 minus 3 is negative 2. So these would be your final coordinates. And if we double check with those, well, G is 0, negative 2, so 0, negative 2. H is 2, 1, 2, 1, there's H. And J is 4, negative 2. So they all match up with what we did right on here. So you can do it geometrically right on the coordinate plane, or you can do it algebraically by just substituting in what you know the translation is. Both ways will get you to the final coordinates. Both ways work. So let's look at our next one. So our next one, we have a quadrilateral, and it says, and this one we don't have a coordinate plane, so we're going to try this one without the coordinate plane. It says quadrilateral ABCD has vertices A, 0, 0, B, 2, 0, C is 3, 4, and D is 0, 4. And we are going to find the vertices of the quadrilateral after we do a translation of 3 units left and 2 units down. So 3 units left and 2 units down. What I like to do, well, 3 units left, that means x is going to go to the left, so x minus 3. And 2 units down, that means y is going to go down, so y minus 2. So each one of these vertices is going to go through the transformation of, I'll write it in vector form, x minus 3, y minus 2, x minus 3, y minus 2, x minus 3, y minus 2, and yep, x minus 3, and y minus 2. And if you want to show the work for these, all you would be doing is substituting in x, so 0, 0 minus 3, that's going to end up at our a prime. 0 minus 3 is negative 3, 0 minus 2 is negative 2, so that's where a prime is. B prime will be 2 minus 3, so 2 minus 3 is negative 1, 0 minus 2 is negative 2. And C prime, you're going to have 3 minus 3, which is 0, and 4 minus 2, which is 2. Last, we have D prime. We have 0 minus 3, which is negative 3, and 4 minus 2, which is 2. So these over here in black are primes. Those are the image. Pre-image in red, image in black. This is where we end up after the transformation. Alright, so let's look at a couple of others. Actually, we'll just do one more, then you could try some of these on your own. Our last one, we have some images already graphed for us, and we are trying to figure out what transformation took place. So we have A, which is 1, 2, 3, 4, right here, and there's a little baseball attached to it, so we'll try to draw that baseball. There you go. That point is part of the baseball. Then we have point B, which is negative 2, 1, 2, 3, looks like 4. Yep, right there. This is point B. And all it would be is a transformation with the ball up here now. And then C was right here. So this is what we're given for this last one. And if you look at the picture, because the picture is better than mine, notice that the baseballs are identical, like they haven't been rotated around. Like the point that we have in each one is in the exact same spot. That indicates we have a translation, that we're just sliding around. So we want to figure out what's the translation going from point A to point B first. So to go from point A to point B, what translation took place? In order to do this, you need to figure out what's your pre-image, what's your image. So since we're going from A to B, we're starting at A, we're ending at B, this is the pre-image, this is the image. And we want to say what transformation took place. So it's going to be X and Y. We're either going to add or subtract, we're either going to add or subtract. So from A to B, we go, let's see about our X, we're going to go over 1, 2, and then up 1, 2, 3, 4, 5. So if we went to the right by 2, we're going to be plus 2. And then if we went up 5, we're going to be y plus 5. It's important to know where your pre-image is, because if you started at B and went to A, you would be subtracting instead of adding. So you need to know where you're starting and where you're finishing at. Alright, and our next one we want to figure out, so that was the first one. Our second one, we want to figure out what would be the transformation, or the translation here, going from C to A. So we'll do this one in orange. Going from C to A, so C is your pre-image, A is your image, meaning you're starting at C, you're finishing at A. So we're going to go 1, 2, 3, 4, 5, 6 to the left. Since we're going to the left, say minus 6. And we're going to go down 2, so it would be Y minus 2. So this would be going from C to A. Whereas the green was going from A to B. And this is what translations are. They're just shifting around. You're going left, right, up and down, but you're not rotating around and you're not reflecting over. You're just sliding around the coordinate plane. And we can notate like this. Or if you want to, you can use vector notation. You'll see this as well. And that's all these little symbols are. They just mean it's a translation. They're specific for translations. That's all they do, is they indicate we're doing a translation. So you can use those if you want as well. Alright, and that's all we have for today, so go ahead and practice some of these on your own. Have a good day, guys.